Okay, let's unpack this. Picture this. A galaxy that's, well, tiny by cosmic standards, yet it's putting on a star-making show that's pretty mind-blowing. Today, we're diving deep into the source material on NGC 4449. It's a dwarf galaxy, but its cosmic impact, anything but small.
Yeah, what's really fascinating here, I think, is how relatively close it is. We're talking just 12.5 million light years away.
Yeah.
And being that close gives us this unique window into some pretty fundamental galactic processes. It challenges some ideas.
Right. So our mission for you today, let's try and understand why this cosmic starburst is such a big deal and, what incredible details the Hubble and now the Webb telescopes have managed to pull out. Because usually when you hear dwarf galaxy, you think small, quiet, maybe a bit sleepy.
Exactly. That's the common picture, and it's precisely why NGC 4449 is so, well, intriguing. It is much smaller than our Milky Way, fewer stars, all that. But don't let that fool you. It's cranking out new stars at this incredible rate, way more than you'd expect for something its size. That's why it gets the label starburst galaxy.
Okay, so it's not just about being small, it's the sheer intensity of the starburst that grabs you. What does that tell us about how we understand galaxies evolving, especially the little ones?
Well, it fundamentally challenges our models.
Yeah.
Really. We often thought, that this kind of superactive star formation was mainly for the big spiral galaxies, or maybe during huge mergers. But NGC 4449 shows that, nope, smaller galaxies can be incredibly productive too. And what's really interesting is where it's happening. It's not just huddled in the center. You see these bright young star clusters scattered all over the place throughout the galaxy. That widespread activity is a key piece of the puzzle.
That widespread activity. Yeah, the sources really emphasize that. Usually you might think, okay, internal stuff, gas collapsing in the core, maybe. But here the source material suggests something external. Something's giving it a push.
That's where it gets really compelling, yes. Scientists are pretty confident this burst, this frenzy of activity, was triggered by gravitational interactions, with galaxies nearby, like a cosmic nudge or maybe even a series of them.
Ah, okay. So its neighbors are stirring the pot, basically.
Pretty much. And because NGC 4449 is so close, it lives in the M94 group, which is near our own local group, it gives us this rare, really valuable chance. We can study the mechanics up close, how galaxies influence each other, how those gravitational tugs can squeeze gas together and, bang, kick off new waves of star formation.
And the views we get are just spectacular. The Space Telescope gave us these incredible pictures. There was a great one from 2007, and newer ones adding more data. You see hundreds of thousands of stars, vibrant blues, reds.
Those hot bluish-white clusters really pop. And then you have the dustier reddish areas where the star formation is happening right now. You can even see these huge dark clouds of gas and dust sort of silhouetted against the brighter background. It's quite dramatic.
So Hubble let scientists really dig into its history, right? Figure out its star-making past.
Absolutely. Hubble's observations let them chart the star formation history over time. It's like reading the galaxy's diary. But that naturally leads to the next question. Okay, what can the newer tools add? What else is there to see?
Enter the James Webb Space Telescope. It's also looked at NGC 4449. It's known as Caldwell 21, too, by the way. And it's 2024 image.
Wow. It shows even finer details. These, intricate tendrils of dusty gas.
Yes, and you can see them glowing. That's the dust being lit up by the intense radiation from all those young, hot stars embedded within. Webb gives us that crucial infrared view. It lets us pierce through the dust that can block Hubble's view in visible light.
So you see the really early stages, the stuff hidden before.
Exactly. It's like getting an X-ray of the stellar nursery. We see the process of starburst starting, the gas getting compressed, and just unprecedented detail. It complements Hubble perfectly. So wrapping this up, you've seen how this galaxy, NGC 44449, it might look small, but it's a real powerhouse of star formation. And it seems it's driven not just from within, but by these fascinating gravitational nudges from its cosmic neighbors. It's giving us invaluable clues about how galaxies, big and small, grow and change.
It really makes you think, doesn't it? If these sort of subtle gravitational tugs between neighbors can set off such a spectacular firework display in a little dwarf galaxy, what other subtle, maybe almost invisible forces might be shaping other parts of the universe? Maybe the quieter corners we haven't really understood yet.
Definitely something to ponder next time you look up at a clear night sky.